is recursion? Recursion sounds very simple on the surface. Recursion is a function that calls itself. So it feels like we're setting up ourselves for an infinite loop situation or a self-referential argument like in in politics or in other areas, or if you're arguing with your kid and your kid says, well, I have to do that, and you say, well, why do you have to do that? And they say, because I have to do that. That's a circular argument. And in recursion, that's kind of what we're doing. We're writing a function that actually has a call to that function inside itself. What does that actually look like in code? Here's a very simple recursive function. This is a function that counts down from whatever number we give it to start with all the way to 0. And all it does is it says, okay, when we call that, we're going to give it a number. It's going to print that number. And then it's going to say, if that number is bigger than 0, then we're going to call this function with whatever the number was minus 1. So we're calling that function inside itself all the way down. Let's take a look at that. So there's my function. And if I want to count down from 5, then I should probably start by running the correct function. There we go. Okay, so there, it counted from 5 to 0. Not that impressive. We can do that with a while loop. We can do that with a for loop. We could just print the numbers from 5 to 0. There are a lot of ways to do that are very easy. But the interesting thing about that is that you can see here that what it's doing is it's creating a piece of itself inside itself. So in this function, it's spawning another function, which comes through and spawns another function. And we're going 6 levels deep before that function ends. So if I say, int counter, if I put that in there, okay, if this was a normal loop and it wasn't recursive, what it would do is it would print the next number down, and then it would say finishing. So I'd say 5 and then finishing 5, 4, finishing 4. But the interesting thing when we're talking about recursion is that it's going down a rabbit hole right here. It's going inside itself, 6 levels down, and then it's coming back out. So what we're going to see here is something interesting in the pattern of responses. So let's run that and see how that looks. So here is why recursion is so interesting and also so difficult to understand. So we're going down, down, down into those levels inside each other. And then just like those Russian nesting dolls, now we're putting the bottom half on each one of those, coming back out of that recursive hole that we went into. So recursion is interesting. And I think in showing you this, I kind of pointed this out already, but sometimes, in a lot of cases, there are other ways to do things that don't involve recursion. And a lot of times, those ways are simpler, easier to write, easier to update. There are occasions when recursion is the best solution. And there are occasions when recursion is really powerful. This is not one of those occasions. There are many occasions when recursion is just a fancy way of it's sort of a nerd flex, right? It's like, look at what I can do. But